A second review. This is going to correspond with video number 7. So I'm just going to walk through the problem step by step. That way, in case anybody needs any extra practice and needs to see how those are done. So we'll go ahead and get started here. Problem number 1, IQ scores are normally distributed with a standard population standard deviation of 15, so that's our sigma. We wish to estimate the average IQ for all students at Ohio State. A random sample of n equals 32 is collected, and a sample mean, so that's our x bar, is 115.25. What type of confidence interval would we use? So because we know what sigma is, that indicates to us that we are going to use a z-interval. Construct and interpret the 95% confidence interval. So I'm going to go to stat, I'm going to go over to tests, and I want to choose number 7, which is called a z-interval. So remember here we have the option of data or stats. They did not give us data. Data would be a list of values. It would be the 32 IQ scores. We don't have that. We just have stats. So we were told that sigma is 15. We were told x bar is 115.25, and we have a sample size of 32. 95% confidence level, so I'll keep it at that. So we have a confidence interval of 110.05 to 120.45. And sorry if you can hear Reed in there, he's watching Pokemon. So my interpretation, we are 95% confident that the true mean IQ of all OSU students is between 110.05 and 120.45. So what is the critical value, margin of error, stuff like that? So again, as I've always said, it's important to know how to do this in the calculator just for the simplicity, but also we want to be able to do it by hand because we have to be able to find certain things that the calculator's not telling us. So for our critical value, so this is our z critical, we know, because it's 95%, we know it's 1.96. But just to tell you one more time how to find that, in case you don't know, it's going to be inverse norm. Then we have to put in 3 things. So the first thing is the area. So if it's 95%, you have 5% left. You have to divide that by 2. So we can do 5 divided by 2. And then we have to turn that into a decimal, obviously. So we're going to put 0.025. And we treat this as a standard normal distribution, so 0 and 1. So you can put that in your calculator. I can show you that real quick. Second vars, inverse norm. So 0.025, 0, 1. So 1.96. And remember, don't worry about the negative because we use a plus or minus, so it's fine. So your margin of error, you can actually get a couple of different ways. If you want to do it by hand, margin of error is plus or minus z critical times sigma over the square root of n. So we have all those values now. You could plug those in and get that. You could also use your interval. We know that our mean is right in the middle, 115.25, so I could find the distance from that point estimate to the end. So if I do 115.25 minus 110.05, that's going to give me the margin of error. So my margin of error is plus or minus 5.2. So that's that wiggle room, that give or take. What sample size would reduce the margin of error to plus or minus 3? So now I have to use this formula. So I'm going to put 3 in as my margin of error. I don't really have to worry about the plus or minus right now. My critical value is 1.96. Standard deviation is 15, and I am trying to solve for n. So the first thing I'm going to do is divide both sides by 1.96. And for something like this, try to keep everything in your calculator so that you don't have to round until the very end. So for the sake of writing my steps, I'm just going to write 1.53, but I don't want to use that in my calculator. So then 15 divided by square root of 9. So I'm going to multiply both sides. I said square root of 9. I meant square root of n. Sorry. So 1.53 square root of n equals 15. Divide each side by this 1.53. So in my calculator, I'm going to do 15 divided by, and I want to use that answer. So I'm going to hit second negative, and that's going to give me the A and S that I'm looking for. It's going to use the previous answer. So I now have square root of n equals 9.8. And to get rid of the square root, I have to square both sides. So I'm just going to hit square to square my answer. And we can't have a partial person, so we always round up. So we need to have about 97 people to reduce the margin of error. Okay, question 2. The EPA would like to estimate the nitrogen oxide emissions for all compact cars. They obtained the following data on n equals 7 compact cars. Sorry, I'm trying to... Okay, so this is one where they actually did give us a data set. So the first thing that I want to do is I want to go into stat, edit, and I'm going to put in this list. So let me clear out all my old lists first. Not sure what all this stuff was. Okay, now I can put these in 0.06, 0.11, 0.16, 0.15, 0.14, 0.08, and 0.15. So it should have 7 values. That's good. Okay, so nothing was given on this. No sample mean, no sample standard deviation, nothing. We were just given the data set. So the most obvious thing that's missing is the population standard deviation, and we have a very small sample size. So this means we're going to use a t-interval. Now, be careful here. They want us to use a 90% confidence interval. Okay, so when I go to stat, over to tests, now we have decided we're going to use a t-interval. So I'm going down to option 8, and this time we have data, so we want to make sure that we select data, and that actually makes the problem a whole lot easier because it bases everything off of what we have in L1. So the only thing I have to do is change that confidence level to 90, and then I'm pretty good shape here. So 0.09 to 0.15. So these are the nitrogen oxide emissions, and I'm not sure what the units are for that. Some of y'all in some upper level science might know better than me. So we are 95% confident, no, sorry, 90% confident that the true mean nitrogen oxide emission for all compact cars is between 0.09 and 0.15. Okay, so margin of error. Again, you have the option to use the formula or use your interval. So you'll notice on the calculator over here, they give you the interval, they also give you the point estimate. Now, I might be more inclined to use the formula on this one. because if I try to use that point estimate, I'm going to have to do some serious rounding because we have a big nasty decimal. So I'm going to do plus or minus t critical times s over the square root of n. And this is going to be good review because we need to know how to find t critical. So that's inverse t, and that's our area and our degrees of freedom. So our area, if we're doing 90%, 100 minus 90 is 10. That 10 has to be divided by 2 to put 5% in each tail. Okay, just a minute, buddy. And degrees of freedom is equal to n minus 1. So we had 7. 7 minus 1 is 6. So second vars 0.05 and degrees of freedom 6. These videos are going to be interesting, guys, trying to make them at home. Have the dogs barking. I got Charmeleon in here. So margin of error equals plus or minus. Hey, just a minute. 1.943. I would carry that out a few places because, again, we have the same issue with rounding. We could actually use our calculator to help us out a little. Shoot, I forgot to write down what S was. So I'm going to have to use that or run that test again. And this is square root of 7. So let's see here. Okay, so S 0.0389, trying to round as little as possible. And I'm going to do divided by square root of 7. Then I have to multiply that by my critical value. So I've got 0.0286, and whatever that unit is. Again, I'm not sure. Okay, question number 3. As soon as I see this percent, I know that this is going to be a 1 prop z interval. What type of interval? Okay, so that's fine. Construct and interpret a 95% confidence interval for the true proportion of NCAA athletes who complete their degree. Now, when you run this in the calculator, you need 2 things. You need x and you need n. What we have here is we have n, our total sample size. However, we do not have x. So what we have to do is we have to figure out what x is by calculating 79% of our total. So if I do 0.79 times 875, I get 691.25. Now, one thing that I want to show you, if I do 691 divided by 875, I get pretty close to 79%. If I round that up to 692 divided by 875, I get 79.08. So basically, you just kind of want to go with whichever one is going to be closer, which you will normally get by rounding this number to the nearest whole number, because this one is only off by 0.03, whereas this one is off by 0.08. So I'm going to be more inclined to use 691. Okay, so now when we go to stat, over to tests, we are looking for the 1 prop z interval. So you got to scroll through all these tests to get to your intervals. The tests are coming up next, so don't panic too much. 691 875. It wants us to do a 95% confidence interval. So here is our interval. Okay, so I've got 0.763, 0.817. So we're looking at about 76.3 to 81.7%. Okay, what sample size will reduce the margin of error to plus or minus 1%? Okay, so we have to know our formula here for margin of error for a 1 prop z. So this is going to be z critical square root of p hat times 1 minus p hat divided by n. So we're going to fill in everything we know. Because it's 95%, z critical is going to be 1.96. P hat was 79%, so remember we use a decimal. And then what I'm going to do is just instead of putting 1 minus 79, I'm going to go ahead and compute that. And that'll just make my math a little bit easier later. And that's divided by n. Now, when we make this equal to the margin of error, what you have to remember is we always convert percents to decimals. So we don't just make this equal to 1, we have to make it equal to 0.01 to convert that to a percent. So first step is going to be to divide both sides by 1.96. So I've got 0.005. 0.005 equals the square root of 0.79 times 0.21 divided by n. So I got to get rid of that square root, which means I have to square both sides. So I'm just going to square that answer. And this is where we get our nasty scientific notation. I'm going to multiply both sides by n to get that over there. So now what I have to do is 0.79 times 0.21 divided by my answer. So second negative. Okay, and sample size cannot be a partial person. So I'm going to say n equals 6.374. We always want to round that up. An NCAA director claims that 84% of college athletes complete their degree successfully. Does your confidence interval support the director's claim? So on this, remember, it's just a matter of does that value fall in our interval? We're 95% sure that the true value is between 76 and 81.7%. So no, because it does not fall in the interval. So plain and simple for that. Okay, question 4. A 95% confidence interval for an unknown population mean is 40.84 to 41.66. Population standard deviation, so that's sigma, is 2.8. What is the value of the sample mean? So that's your point estimate. It always falls right in the middle. So the easiest way to do that is to just average everything. So 40.84 plus 41.66. Get that value, divide by 2. Hang on, buddy. So my sample mean is 41.25. What sample size was used to calculate this interval? So one thing that I'm going to do is from the mean and from the interval, I'm going to go ahead and get my margin of error because that is going to be how I find this sample size, because I know my critical value because I know my confidence level. I know sigma because it was given, and I'm going to know my margin of error. So 41.25 minus 40.84. So my margin of error is 0.41 equals 1.96 times 2.8 over the square root of n. So we've solved a few like this already. Divide both sides by 1.96. So 0.209 equals 2.8 divided by square root of n. Multiplied both sides by the square root of n. So I'm going to have 0.209 square root of n equals 2.8. So I have to do 2.8 divided by my answer, and I then have to square that. And I'm going to round up. So 180 needed for that interval. Okay, Gallup poll recently asked 1,033 random Americans, how often do you bathe each week? Results of the survey indicated a mean of 6.9 and a standard deviation of 2.8. Construct and interpret a confidence interval. So this is based on a sample. So that's going to be a t interval. So I'm just going to go to my calculator and plug everything in. Stat test t interval, so 8. I now have stats. X bar 1033. Sample standard deviation 2.8. Nope. Let's see. X bar 6.9. How about that? Sample size 1033.
I'm starving.
So let's see. 6.73 to 7.07. And at this point, you guys kind of get the interpretation. So I'll write it on the answer key, but I'll skip that part for the video. Okay, I'm going to pause the video. I don't know if I can pause the video actually. Oh, you guys will just have to wait about 5 minutes, okay? And then I'll be done.
I got ice cream, Sam.
Okay, so we have 863 patients who received 10 milligram doses of Lipitor daily. 47 reported a headache. Construct and interpret the confidence interval. So because X and N are all we have, that is a one prop Z interval. So 47 had a headache out of 863. So 0.039 to 0.0, I'm going to call it 70. So we're looking at about 3.9 to 7%. And again, I'll put the interpretation on the key. Hey, Bo, stop, please. So these videos at home are real fun. All right, how does the margin of error change if a 90% confidence interval is calculated instead of a 95? We've drawn this picture a couple of times. 95 is kind of your standard. Your margin of error goes from the point estimate out to each end. Those are equal. So what happens if our confidence level decreases? Well, if we are less confident, that means that it must be a smaller interval because I'm not as sure if the actual value is in there. So, how does the margin of error change if we make it 90%? Margin of error decreases. So then on the other hand, if we're more confident, that means we have a bigger interval to make sure that we actually have it in there. So margin of error increases. So last problem, just finding some critical values. So anytime we see z critical, that means you're going to use inverse norm. Anytime you see t critical, you're going to use inverse t. Now for inverse norm, you need an area, a mean, and a standard deviation. For inverse t, you only need two things. You need an area and you need a degrees of freedom. So even though on question A, I gave you a sample size, you actually don't need that to find your critical value. So if it's 95%, you have 5% left over divided by 2. So that's 2.5% in each tail. And we use 0 and 1. I'm telling you, I miss y'all. This being stuck at home with the little ones is nuts. Okay, we should already know this one, but just to show you, it is plus or minus 1.96. So now, oh my gosh, my house is going to be destroyed. Okay, inverse t, 95%, cut it in half, 2.5% left in each tail. Degrees of freedom is n minus 1, so that's 18. So, plus or minus 2.1. I'll just call it 2.10. So, I'll put the others on the answer key. I've got to go because Bo is going to rip the door off the refrigerator.